Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ya, selamat siang dan salam sejahtera untuk kita semua. Baik, pertama-tama izinkan saya ucapkan terima kasih kepada seluruh peserta yang telah hadir di ruangan hari ini ya, atau di acara hari ini. Khususnya pejabat universitas, Fakultas Teknologi Informasi Universitas Yarsi, terus juga kepada narasumber kita Pak Andrew Putra Twinanda, keluarganya selamat datang di Universitas Yarsi ya. Oke, baik, mari sama-sama kita buka diskusi kita ya hari ini dengan baca basmalah. Bismillahirrahmanirrahim. Ya, hari ini kita kedatangan salah satu narasumber yang sangat expert di bidangnya ya. Beliau akan sharing dengan kita dengan tema For Lesson in AI from Academia to Industry. Sebelum kita mulai, saya akan membacakan secara ringkas ya CV beliau. Oke. Ya, beliau saat ini menjabat sebagai AI Research and Development Manager di Intel sejak tahun 2020 ya. Kemudian di sana beliau juga memimpin tim pengembang baik back-end dan front-end untuk platform Intel GT, dan kemudian membina tim engineer untuk mengembangkan solusi deep learning open source yang mencakup seluruh siklus hidup machine learning. Kemudian sebelumnya beliau juga merupakan Director of AI di perusahaan Cosmonio yang fokus pada pengembangan sistem computer vision untuk pengguna non-AI ya, artinya non-expert AI. Beliau juga memiliki latar belakang akademik, background education beliau adalah di PhD dan postdoctoral di University of Strasbourg, Prancis. Kemudian beliau juga memiliki skill keahlian yang mendalam di bidang AI, khususnya di visual deep learning, large language model (LLM), VLM, kemudian berbagai tools industri seperti PyTorch, TensorFlow, dan arsitektur microservice lainnya ya. Terus baik, saya juga ucapkan terima kasih, selamat datang juga bagi rekan-rekan mahasiswa yang juga sudah bergabung di Zoom ya. Kita sudah ada sekitar 40 partisipan di Zoom. Terima kasih atas waktunya. Baik, tidak menunggu waktu lama lagi, saya persilahkan Pak Andrew Putra Twinanda PhD untuk sharing sessionnya ya. Terima kasih Pak, silakan.
Yeah, terima kasih, Pak. First of all, I would like to ask everyone that to allow me to speak in English because it's going to be a little bit technical, so it's a lot easier for me to speak in English. So, thank you. Yeah, first of all, I would like to thank Mr. Fasli Jalal, who cannot be here. He invited me to give the talk a few days ago, and I'm really honored to be able to speak here in front of esteemed faculty members of the informatics engineering, as well as the students as well. I'm hoping that what I can share today will be very useful for everyone. And what I'm going to share here is the lessons that I have learned in AI. I come from academia. I did my PhD and postdoc, and I moved to the industry. Now, as mentioned, I'm currently the AI Research and Development Manager at Intel. Maybe next. So to give a little bit of an overview of my experience, so I did my bachelor in Indonesia in ITB in computer science. My thesis was about topic sentence identification for scientific paper using support vector machine. This was my first big project in AI. Of course, you know, as students, we learned AI, we got like assignments from courses, but this was the biggest project that I did in AI. And this is why I fell in love in AI in a way. Then in 2011 to 2013, I moved to France to study masters in computer vision and robotics. So this is where I gathered my expertise in computer vision, in image processing, as well as robotics. My master's thesis was more on the robotic side, that is the simultaneous localization and mapping, but of course related to image processing. Then in 2013 to 2017, I finished my PhD and postdoc in France. And this is the time that I start getting into deep learning, or AI as we know it now, the neural networks. The topic of my thesis was about operating room optimization. And the idea is that we wanted to minimize the idle time of operating room through laparoscopic videos. So laparoscopic videos are when the cameras are inserted inside the stomach, abdominal cavity of the human, and that what we're trying to do, looking at the images, how far or how long is the surgery going to take, just based on the images that the camera is seeing. And the idea is that we want to optimize the operating room usage so that the next patient can be prepared earlier or on time, and then the next surgeon can be notified in time as well, because that's the main cost of operating room management. So that's the goal of the PhD. Moving forward, I moved to the industry. After 4 years in academia, I decided to move to industry. I joined a startup in the Netherlands, in Cosmonio, as a director of AI, and I was the 4th employee of the startup company. So it was very exciting in a startup company as a 4th employee. I got to learn fast, fail fast, learn a lot from the customers, learn a lot what people are doing in the industry. So it was very exciting. In 2020, during COVID, when COVID hits, it was actually a very difficult time because our customers in the startup were actually failing as well. And you can imagine if our customers fail, we fail. But luckily enough, Intel was interested in us. Intel was interested in what we were doing, so they fully acquired us, all our intellectual properties, as well as all the employees. So that is why from 2020, I have been the AI Research and Development Manager at Intel. The work itself that we're doing, it's the same. So from Cosmonia and Intel, it's the same or similar platform. In Cosmonia, it's called Naus. At Intel, it's called Intel Getty. So for those of you interested what it is about, feel free to check it out online. It's getty.intel.com, and you will get more information about what it is. But the idea is that we want to democratize AI. What we mean by that is there are a lot of subject matter experts who are experts in their own domain. You can say doctors, they're experts in medicine. Farmers, they're experts in the produce. A lot of subject matter experts. They want to automate their process, but they do not have AI knowledge. So there is a barrier for them to enter the field. And this platform is to break that barrier. So as long as the experts have their data, and then they know what the problem that they want to solve, for example, classification, detection, segmentation, then they can use our platform to train their own neural networks. So that's the goal of the platform. It's basically AI democratization. So that's a bit of a longer explanation of where I'm coming from. And what I want to share is the 4 lessons that I have learned both in industry and also in research. What I want to share here, it's a little bit geared towards industry, but it doesn't mean it's not applicable to research. These are very generic learnings that I've, gotten during the process. The first lesson is we need to understand the problem. As Albert Einstein once said, a problem defined is a problem half solved. We really need to understand the problem that you are trying to solve. One thing that I would like to highlight here is we need to distinguish between programmers and engineers. here, because we call the major as technique, you are trained to be engineers. The difference between programmers and engineers are, programmers are people that can write code. Engineers are people that can write code to solve problems. This is a very important distinction. And you need to really understand this. And then you will learn along the way that being an engineer does not stop at writing code. You have to make sure that your code solves problems. I'm going to expand a little bit more. Maybe for some of you who have taken project management courses, the graph on the left, it's quite familiar, is the SDLC, Software Development Lifecycle. It's a classic graph. It starts with requirement analysis, you move to design, implementation, testing, and then maintenance. This comes with different flavors, different wordings, but the essence of it is the same. It's always this cycle. And what I want to highlight here is the first step, the requirement analysis. I want to make sure that this is being highlighted because this is a very important step. And on the right side, you can see a comic. It's a very funny comic that I find. You might not be able to see it, but it's basically showing on the first side, at the first image, it's basically the customers explain what they want. And then the second image is how analysts understood it. The next one is how a project manager understood it. The next one is how business development understood it. It's basically highlighting the problem of problem definition. Every person has a different perception of what the problem could be. And then at the very end, you can see the customer actually needs or wants something that is very simple. So this highlights the problem of requirement analysis. When I saw that picture, I thought it's funny, because it's funny. But it is unironically funny when you see this in the real world. It is not funny, in fact, because it is a very problematic issue. So again, why is requirement analysis important? I'm pretty sure in your course you learned why this is important. But these are like the essence that I have gathered myself. The first one, requirement analysis is the very first step of the process. This is the time that you discuss with your customers what are your problems. You make assumptions of what the problems want or need. Any assumption you make, it will be carried throughout the process, throughout the steps. And that means any mistake in your assumption will be carried throughout the process. And this is a very expensive mistake because it's carried throughout the process. Speaking of expensive, time is expensive. Everybody's time is expensive. Your time as an engineer is expensive. But the most important person in this process is going to be the customers. The customer's time is very expensive. You do not want to do all the implementation work, testing, and everything to find out that you're not actually solving the customer's problem. Just to call back, I'm saying customers here. As I mentioned, this is also applied in research. When you're doing research, the first thing you do is, what is the research question? You can see research question as your requirement analysis, because these are the problems that you're trying to solve. If you do not define your requirement or your research question properly, then your research is not going to be structured properly either. Your results will not solve the actual problem that you want to solve. So again, this is also applicable to research. Things to look out for during the requirement analysis. First thing is, of course, miscommunication. So the comic pictures that I showed, it shows all the miscommunication problems. But the second point is, customers can describe the solution they want instead of focusing on the problem. And this is a problem because customers might have limited technical information. But with the technical knowledge that they have, they think that I want that solution. But that is not the right way. You have to be really careful. When you see this happening, you have to be really careful. Because it is not their problem to describe the solution. It is our problem as engineer to describe, to design the solution that fits our customers. Whenever customers do this, you need to ask why. You need to ask why. The customers will explain, yes, because I want this, 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 this. Sometimes the why, the answer to the why, it's because it's cool. Just because it's cool. AI is cool. Everybody wants to do AI. But is it the right solution to the problem? Does that bring value to the customer system? That's what we need to think as engineers. Note that bringing something cool to a system, it is a cool thing. It is a valuable thing. But you have to be, everybody has to be honest about it. Everybody has to be, yes, we're doing this because it's cool. It's not because we're pretending to solve some problems that do not exist. That's very important. Going back about programmer engineer, just something that I would like to impart is, as an engineer, your best achievement is not to make code that works. Your best achievement is to make work that is useful. You will soon find out as you leave, when you go to the industry, when you do your research, when you see that your work is being used out there, that's the best gratification that you will bring, that you will have. It's not the fact that you write a very fancy code that works. Yes, of course, it brings you satisfaction. But when you see your work is useful, that's where the real satisfaction starts. So that's the first lesson. The second lesson is about do not fight the AI current. I think I do not need to go into details of this one because you guys are studying AI, some of you are studying AI, some of you are already aware of what AI can do, I imagine. So I don't think I need to go into the details of this one. Just a quick preview of AI, maybe not all of you is aware. So I come from image processing, and I deal with images and videos every day, all day. And I want to make the distinction between conventional and deep learning, because this is, this is an introduction of what I'm going to say. So imagine you have a problem of distinguishing cats' images from dogs' images. This is a very simple example, right? There are two ways. Previously, before deep learning, before neural network, what you do in conventional AI, I think the faculty member would remember this. The first thing you do is you look at the images and then you see, how do cats look different than dogs? We start looking into, okay, the colors look different. The eyes look different. We start thinking for ourselves, how do we distinguish cats from dogs? And then we start extracting features. So maybe the color channels, maybe some key points, interesting key points. So that's conventional AI. You start with the handcrafted features yourself, and then you pass it to AI algorithm. This is different than deep learning with neural network. With neural network, you do not do this. You just pass your data, you pass the class, and then the neural network will do everything for yourself. You do not need to think for yourself what is the distinguishing features for my problems. Now I want to show you my AI timeline. So when I started my PhD, neural network, deep learning was just starting. When I started, I was not aware of deep learning. I started with conventional AI, those color channels and then the key points that I showed you. In 2012, AlexNet was published. This was the first paper in image processing to show how promising it is, neural network is for image recognition. It beats all competition, all other algorithms by a landslide. It's huge. And mind you, neural network is not something new. Neural network has always been there since the 40s, 1940s, 1950s. We know this algorithm exists. But at the time, AlexNet, the creators of AlexNet, found that by using GPU, NVIDIA GPU, I think at the time 580, it could solve the computational issues that neural network has. That was the main issue. It's really difficult to train neural network. Theoretically speaking, neural network is just multiplications and additions and some fancy mathematical operations. In theory, it can model anything in the world. The problem is that it is so difficult to train it, to optimize these parameters. That is why it has never been, even though the algorithm is known 60, 70 years ago, but it just started in this decade because the hardware is now able to do this. So that's what they did in 2012. However, in 2013, I was not aware of this. I was stuck with my conventional AI, and then I was really successful. I had my papers, I did my research with the conventional AI, looking at the, not deep learning, and I was very happy with my results. In 2014, an intern came and then said that, hey, we really should look into this AI stuff, deep learning stuff, because it seems very cool. It looks very good, it gives very good results. Me being, I'm just sharing that I was a part of the people that was against the current. I was saying that, oh, well, it's a different type of data that they were working on. They were working on cats and dogs and flowers. I was working on laparoscopic videos. This thing will not work on my data. So I was against it in a way. And then I was also, my work is giving good results. I got journals, papers, things like that. So why do we need to move? But in any case, we allowed the intern to, okay, please look into this and then I will help you out. 2015 was the very first successful experiments that we did with deep learning on my data sets. And in 2016, I was lucky enough to be one of the first papers to publish the results on the type of data that I was working on. And at the moment, it is one of the highest cited papers in the field, in the medical imaging field with this type of data sets. So you can see here, from 2012 to 2016, it is a 4-year difference. I was lucky enough that I managed to hop on the AI train, the deep learning train. However, I was against it. So what I'm trying to say is, it is impossible to fight this AI train. Do not try to fight it. Try to hop on it, try to learn from it, and take advantage of it. That's the only way we can do. So, where AI is now. Everybody knows about ChatGPT, of course. I'm pretty sure the faculty members are having a hard time with plagiarism. So, I can imagine that. It's very easy now to ask ChatGPT to write code for you. I want to share something that is very cool. I found this perhaps 2 months ago, something like that. It's crazy how fast AI is. Maybe some of you are already familiar. So remember in my bachelor's thesis, I was working on scientific paper summarization, right? So that you can read the summary of scientific papers in a short manner. Now, AI, of course, can do that. It's easy for them. It even goes one step further. I tried uploading 2 different papers, to this platform. And this platform can provide a podcast discussing of these 2 papers. And then I heard this from one of my engineers as well. And then I said to him, yeah, but it's not going to be good. Like, the voice is going to be very robotic, and then it's very awkward. And then he sent me this recording. So this is So this is an 18 minutes podcast generated by AI regarding these two papers.
Like this. We've got some fascinating research today, all about customizing this powerful new AI tool called SAM, the segment anything model.
Yeah, that's right.
It's already making waves for its ability to segment, well, anything.
Yeah.
But these papers we're diving into today, they're exploring making it work even better for specific.
This goes on for 18 minutes. You hear how natural it is. It's a conversation between two people discussing two new papers that you just uploaded to a system. It's not like somebody making a podcast about it. It's you. And you can upload any papers. You can upload 3 papers. You can upload 4 papers. And then they're going to go into the details of comparing the algorithms. It's crazy. But it's also exciting. Imagine how useful this could be for education. A lot of people in education are dyslexic. The amount of time that they need to read papers are much more than what we usually would need. Imagine the inclusivity. People who cannot read would be able to learn as well about AI. And then it's not by somebody teaching them, but it's actually AI just reading the papers and then narrating it for them. Imagine how crazy is that? My bachelor thesis was nothing compared to this. And this was only within 15 years. The amount of time, it's not a lot at all to reach this type of progress. I have another demo, but for the sake of time, I'm not going to show it. But I just wanted to show about how ChatGPT can easily generate code, working code for us. Well, previously, when it comes to user interaction, it is very difficult to write it, especially for people who are not used to writing code with GUI. But ChatGPT can do this for you very easily. Okay, so now, what are we all doing here? It sounds very depressing in a way, especially for you guys who might just start, your computer science journey. Well, AI can do everything. In fact, it is not the case. Yes, AI can do a lot. By no means AI cannot do anything. It can do a lot. But in industry, there is something called 90-10 rule, which means 90% of the work is at the last 10% of the project. In a project timeline, you start with your code development when it's already start coding. And then you start, writing your classes, writing your tests, writing your functions. And then at the end of a project, what you do is you do code cleanup, you do finishing touches, and then you start integrating your system with your project with other systems in the company. So you need to do integration. And what's happening here is that in the first part, AI could help you, but in the last part, AI cannot do this. They cannot do this yet. This is where you guys come in play. As engineers, this is what you are going to do. Note that AI also doesn't give perfect results. AI can also give you wrong code, and then you will need to fix that code. If you do not know how to fix code, then you will not be able to do anything with what AI is doing. On top of that, there are still a lot of problems that are unsolved with AI. Me coming from the vision world, there are a lot of problems. I'm just going to mention them about the visual prompting. We call it zero or few shot learning. In the visual language model, we want to do video indexing. Sounds science fiction, but what we want to do now is you have a lot of videos, and then you want to be able to find subsection of a video based on your text prompt. So for example, maybe a traffic. You can say, give me video segments where there is a red car with this license plate. That's the goal, what we want to have. Some sort of a system that is able to interact with videos and also with the prompt. And here what I would like to highlight again is having technical expertise is important. You saw what AI could do already, but it doesn't mean you need to despair and things like, well, I will not be able to do anything. No. You only need to do the AI. No. You need still have all the basic knowledge, data structure, database, object-oriented programming, network. All those will become useful in the long run. An analogy, just because calculator exists, it doesn't mean you do not need to know how to count. Like multiplication, addition, things like that. You still need to learn that. Similarly, just because AI exists, it doesn't mean that you do not need to know about this programming knowledge anymore, different types of languages anymore, just because AI can already write the code for you. You still need to have these technical expertise. Next lesson is how AI is not about model development. I think everybody knows about this already. I heard that the majors here, it's not only about AI, but there is also IoT, which is great because that's where AI is going to be, in the Internet of Things at the edge. And then there's also the mobile and other types of majors here. So AI is not just about the model development. It's not about these weights and the training only. There is a saying that I really like here, where in a gold rush, sell shovels. What it means is that when everybody is gold mining, you would think the business to do is to also start gold mining. But actually, if you sell shovels, it's also a very good business. So what I'm trying to highlight here is that AI engineering is not just research and development of the model. There is a lot of things around it. You need to think first about data. Garbage in, garbage out. The model depends on the data. This is a field on its own. How do you collect data from the experts? How do you annotate the data from the experts? Pre-processing, outlier detection. These are the things that are important as well. The MLOps. This is the day-to-day of AI. How do you package? How do you deploy? Security, reliability. Like ChatGPT has had reliability issues when a lot of people were accessing it at the time. They even had to reduce the amount of users. At the time, they did not accept any new users. So that's the reliability aspect of AI. Infrastructure. Training and inference devices. As I mentioned, previously, neural network was not possible because of the compute capacity that we had was not sufficient. Now, we have big NVIDIA GPUs, both servers and consumers side. But this is not going to be the trend anymore. Nobody can afford NVIDIA GPUs. Not everyone can afford it. So we need to start thinking about moving the training to edge devices, to CPUs, or to NPUs, to TPUs, to more affordable processing units. The inference as well, it's a different problem. Storage and transfer, how do you store the data? It's a big data, it's millions and millions of images. And you have to store it in a proper way, and then you have to transfer it in a proper way to the model as well. And of course, last but not least is the product management. What I would like to say is AI is just a tool. I would like to compare it as C# as a programming language. What you ship to customers is not AI. What you ship to customers is not C#. What is C#? Like, you do not ship C#. What you ship is something on C#. Similarly with AI as well, what you ship to customers is something on top of AI. So customer and user experience is very important here. The last lesson is about not trusting the AI hype. So you have seen in LinkedIn or articles or anywhere in the news about oh, AI this, AI can do this, AI can do that. Such bombastic and fantastic news. Great thing is that we need to understand these news, what they want is your clicks, right? You need to get there. So be careful when you read this type of news. Take it with a grain of salt. Hype misinforms. It's very dangerous to trust hype. A few points. First, fear mongering. These articles would make you think that AI will replace all jobs. I will be out of jobs. So, one thing that I would like to expand here. In the history of humanity, progress will always win. Again, do not fight the current. Progress will always win. The first big pivotal moment in humanity is, if you remember your history lessons. First, we were hunter and gatherer civilization. We hunt, we gather food in the forests, in the woods, everywhere. And then we move to farming, agriculture. This is the biggest, the first pivotal moments. And then at the time you might think, well, then hunters and gatherers don't have jobs anymore. But such is life. This is the progress of life. But you have to think that, well, by farming and breeding animals, the hunters and gatherers do not need to go to the woods anymore. They do not need to risk their lives anymore. So they have more secure life and safe life with their family. So at the end of the day, progress with positive net value will always win. Same with AI as well. Yes, a lot of jobs will be reduced, but a lot of new jobs will be created as well. And AI will not replace all jobs. AI will create so many new jobs that you would never think of. Second, false hope. AI can solve all our problems. You see that, oh, AI can detect cancer at this rate in this research. And then you would start thinking, well, that means AI can solve all our cancer problems. No, that is not the case. So be careful with this slippery slope logical fallacy. Like, AI still have a lot of issues that it cannot solve. The hidden complexities. So that's related to the third lesson that I mentioned, that AI is not just about model research and development. It comes with a lot of other problems with it. Fourth, AI gains a lot of hype. So people tend to, well, I just want to focus on AI then, without actually gathering the context of what AI is, what is behind AI. So I just want to focus on ChatGPT. ChatGPT can do everything for me. So I'm just going to be a prompt engineer, as they call it. But again, it is not sufficient. AI will lead you astray if you do not have the basic knowledge. You will need to have the context of how AI grows, the predecessors of deep learning. So this is my last slide. If any at all, this is going to be the one point that I would like to share. As I mentioned, AI is a tool. I really like this saying. If the only tool you have or know is a hammer, then all problems start to look like a nail. What it means by this is that, and AI is a very useful tool. But it's a very heavy tool as well. To run AI, ChatGPT, the environmental impact and the financial impact to run ChatGPT is astronomical. So it's a very heavy tool, but it works for a lot of problems. Now here, the problem here that you need to focus on is you need to make sure that AI or ChatGPT or neural network is not the only tool you have in your toolbox. The conventional AI that I showed you should be a part of your toolbox, should be a part of your knowledge. So having these basic knowledge, having the network knowledge, operating system knowledge, all of those are going to be very useful in the long run. I'll give you an example of one of my customers. So it is in a warehouse of fruits and vegetables. And then what they wanted to do, they got this boxes of fruits and vegetables, and they want to sort it out automatically. And then they said like, well, I want to use this AI, this neural network, to be able to sort this produce. And I was looking at their data. Okay, yes, neural network can solve your problem easy. It is a very easy problem, 100% accuracy. But conventional AI can also do this. And conventional AI can run at a fraction of the cost that you're going to incur for neural networks. So this just goes to show a few points, actually, that customers leading to a solution right away is a problem, but also you as engineers, you have to make sure that you have the right tools in your toolbox. And during your studies, this is your opportunity to fill your toolbox with all the right tools before you go out there. So if anything, that's the one thing that I would like to impart with you all. And with that, I would like to thank you all for your attention. And if you have any questions, then yeah, feel free to let me know.
Okay, thank you for your presentation, a very nice presentation. I would like to invite all the participants, maybe in this room or in Zoom, to ask questions. You may ask the question in Bahasa. Yeah. Okay, our Dean.
Yes, thank you, Pak Andrew. We know that we already know and we always heard and read about Intel Inside. So please tell us, how about AI in Intel? Or in what aspect? Because we know that Intel in hardware, right? Yes, thank you.
Yeah, no worries. So I mentioned in lesson 3, AI is not just about model development and research. It's about the device that it runs as well. How do you run AI? At the moment, Intel has been focusing at optimizing inference, running inference for neural network. So we have our AI PCs, right? Our AI processors that is to focus on running inference. But we're also starting to move to the GPU landscape as well. So recently, I think in January, we released our Battlemage GPUs with 12 gigabytes of memory and 10 gigabytes of memory. So we also move towards that space, providing hardware for inference, training and inference. Intel also has a framework called OpenVINO, and this is an inference first library. So you imagine you train your neural network on PyTorch or TensorFlow, and then you optimize the network so that it runs faster on CPU, and it's using this OpenVINO. So it's an inference library that is optimized on Intel CPU. So that's the space that Intel is working on in the inference space and in the training space. My team personally is working on enabling people to train their own neural network. So Intel starts moving to the software realm as well. Well, started, it's since 2020. So Intel is covering both the hardware front, inference training, and also with the platform as well, enabling people to train their neural network. So yeah, that's it.
Okay, thank you for the opportunity. Very exciting talk. My name is Chandra. I'm one of the faculty member here. First of all, I'm curious why you prefer to choose in industry than academia, because you already have PhD and postdoc several years, and you move completely in industry. And what is your suggestion for people who also want to have industry experiences? I remember when I attended deep learning and reinforcement learning summer school a few years ago in Montreal, Canada. Almost all of the speakers have multiple affiliation. Jan LeCun from the New York University and also Facebook AI manager. So many of them have affiliation in industry and also academia. Do you think it is a good idea? Or we need to prefer to choose one of them? Okay, maybe you focus on industry, completely leave the academia, for example. And maybe for last question, I also need your suggestion for the AI battleground in Indonesia. Because AI is not limited to the model development, right? Of course, in Indonesia, some of my friends went back from abroad also. We cannot compete in model development, okay? They have hundreds of PhD, postdoc, professor. So we need, for example, we can compete in the application area or in infrastructure or etc. Because we have so much unique problem in Indonesia that we can solve. Okay, maybe that's a question from me. Thank you.
Hello. Yeah, so a few questions there. First, why did I move from academia to industry? One of the main reasons was in research. I was working at a hospital with the laparoscopic videos and everything. I already felt the impact of my work, of my thesis, because the hospital saw this and then they're really interested and then they're really working into implementing it. But I was still missing the impact. Research has a big impact, but the impact is long run. It's not instant gratification. I hear myself, I'm sorry. So that's what I was missing. After like a few years, I saw my impact, but I saw in the industry. I was also coming from the industry. When I finished my bachelor's, I was working in a company for a year. And I could already feel anything that I did the next week, the next month, I could already see the impact. I could already feel the impact, no matter how small. It is not the case in research. I think everybody is familiar. Research, the impact, you see it in the long run. And that was not enough for me. So that was one of the main reasons that I moved to industry. Because with industry, you see customers, you work with customers. It's very quick, the feedback loop. It's very short. So that was the reason. Second, about people having both affiliations. I think it makes sense. Because me personally, I'm also a part of the research and development team at Intel, right? My team develops models. My team research models. So at the end of the day, it's not that I'm leaving research completely. So even in industry, you have to do research, especially in this field. You will be left in the wind if you do not do research. I think for these people who are lucky enough to be affiliated both in university maybe and then in the industry, what I would imagine is that there could be a lot of ways of collaborations between the university and industry. It could be just by name only. It could also be an active collaboration. So there could be a lot of things. I don't think it's particularly bad or good. It's just how it is. There's nothing good or bad about it. So I cannot comment much on that part. The third is how can we develop AI in Indonesia? You raise a very good point that we just cannot compete. As I mean I working at Intel, we couldn't compete with Facebook. We would not be able to compete with OpenAI in model development. They have bajillions GPUs, and they have so many researchers that just focus on that. We would not be able to do that as Intel. Indonesia is going to be the same as well. We would not be able to compete with those people. There is no point of competing with those people. But there are a lot of problems that can be solved with AI. That's the challenge of the first lesson that I mentioned. We need to identify the problems that would fit this AI solution. And a lot of them. There are a lot of them. The last time I was talking, I came here maybe 2 years, 3 years ago, I can't quite recall, but somebody came to me and then asked, hey Andrew, like, I think it was a car dealership, and then what they want to do is that, well, I want to have this AI system that I mount a camera in the dealership, and then it can detect already the customers who are coming in, so I can tell, I can already know their name and then their history, so then when they pass by, there is somebody like a customer service comes already to them and then kind of like, oh, Mr. So-and-so, how are you doing? You know, just to improve the customer relationship. So there are so many problems that can be solved and so many interesting ones as well that can be solved. I think Indonesia can really compete on that. And there's a lot of opportunities in this field. So yeah, that will be my focus.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Herika. I'm from Faculty of Information Technology. I want to ask about the internship opportunities in Intel. Is there any program to our student can intern in Intel? Our faculty have two study program. First is informatics engineering, and second is library and information science. Maybe you can explain the internship for our students. Thank you.
Definitely. So I lead 8 engineers in my team, and then those are research and development engineers. So we are working with the AI lifecycle from data processing, the model training, inference, explainable AI. We are always looking for people who are really excited about AI. So if you guys are interested, you can shoot an email to me and then send me a CV, because we're always looking for interns that can help us out. AI is moving in such a big pace that us as 8 engineers are not able to keep up. So if you have students that are interested, shoot me an email, and then of course we're going to go through the process, right, as normal. And then yeah, we can see how it would work out. The second thing that I would like to say is, not just at Intel, I think it might be good, I'm not sure if it is quite common here to do Google Summer of Code. Google Summer of Code is very useful for students, because 2 things, right? The first thing, so the way Google Summer of Code works is companies approach Google with the problems that they have and they want to get solved. And when the students apply for it, and then there will be interview process, Google will sponsor these students to work on these problems with the company. So it's actually Google is paying you. It's useful in two ways for students. First, by looking at the list of the projects inside the Summer of Code, you know what companies are looking for. You know what projects companies are interested in. Even without applying yourself, you will be able to make the connection, oh, these companies are looking for this type of problem, and these companies are looking for this type of problems. This broadens your knowledge of what is out there, even without applying, just by reading the proposals. And of course, second, if you apply and then you got accepted, then you are fully involved in the process. So I would suggest look into Google Summer of Code. I think the deadline might have passed, but it might be good to include this as a part of the curriculum, maybe looking into this Google Summer of Code, because it's very useful for both the companies and also for the students. So yeah.
Maybe I want to ask the requirement or qualification for the internship in Intel.
What we would like to have, of course, we need somebody who, in my team at least, we need somebody who has deep learning experience, like PyTorch, TensorFlow, things along those lines, Python, and yeah, just good software engineering purposes in general. Because my team is responsible for 5 open source libraries, and as you can imagine, it's open source, so everybody can access it. We do not want to have ugly code in these libraries. So on top of the deep learning experience, we would like to see like good software engineering expertise. So, yeah.
Okay, thank you very much.
About the English, TOEFL maybe? No?
We do not have TOEFL, that type of thing. We just see how they communicate, and that's it. No.
Okay. Any question from other participants, especially students? It is okay. You can provide the question in Bahasa. Ya, untuk mahasiswa yang di Zoom bisa menuliskan pertanyaan juga dalam bahasa Indonesia. Silakan. Ya, silakan.
I have one follow-up question. Okay, so you mentioned about the lesson number 1 about the problem formulation. Okay, either in academia or industry we have problem formulation, but sometimes it has different goals. In academia, we need to publish in journal, conference, and we tend to have quote-unquote easy problem statement, problem that we can make improvement and get published. But in industry, it's totally different. We can make, we really want to solve the real problem. give the competitive advantage, value for the company, then they can sell to the customer. Even for your information, in our AI lab here at TRC, at least 80% of the funding are coming from industry. Okay, so even we have research that maybe we will not publish it. We go to the patent, for example. So have you ever have this kind of conflict between, okay, this is the research output to get published, this is for the industry, and how you manage to solve this one?
Yeah, very good point. So in industry, it is more strict in the sense that the problems of the customers are clear, and then you need to solve this. The research is more flexible. First-hand experience. I had a research question. It was about how to classify, my first research question is how to retrieve video segments of laparoscopic videos based on a video input. That was my first research question. During the research itself, sometimes when you're researching something, you find some other things that you do not expect. This can be exciting or sad. Fortunately for me, it was quite exciting. So during my research, I found a side effect to my method that was actually could be used for other problems. So I abandoned my first issue, and then I focus on this one, because this one is easier, and this one is already there. So might as well publish. So it is, like you said, it cannot be the case in industry, right? In industry, you have this problem, you have to solve it. The side effect, as exciting as it is, if it doesn't solve the customer's problem, you're not going to do it. But in research, it is the case. So yes, in research, you have to be aware of those possibilities as well. When you find results that do not really, or that might be surprising to you, then you have to think of a way to package it in a way that it becomes useful for you, right? Also in research, you start with a research question, you do your research, you get your results. I'm not saying that this is the way to do research, but sometimes when you get the results, you find findings that are not necessarily aligned with your hypothesis. And then you work backwards, right? You try to find a research question and hypothesis that fits with your research results. It's not always the best thing to do, but it also works because it does answer another research question. You might not have been looking into it, but you do answer another question. So yeah, that's my experience when it comes to research and industry with the requirements and research question. With research, you got to be more flexible, and research is flexible, but it is not the case in industry. That is very good observation. Yes.
Okay, maybe one or two questions from students. Okay.
Okay, sir. First of all, let me introduce myself. My name is Anggi. I'm from Faculty of IT. I'm here want to ask that as AI becomes more prevalent, there's a growing concern about bias, privacy, and accountability. How do you think we can ensure AI systems are fair and transparent about that? Thank you.
Yeah, very good question as well. So this type, we all already know about AI art, right? How AI art is stealing from artists without their consent. AI is also stealing people code from GitHub because nobody's on GitHub was notified that, ChatGPT was using this. So there is that. My take on this is governments should handle this. We as the people would not be able to control this. At the end of the time, people in power have to catch up. They will have to catch up to set regulations. And these are difficult questions to answer. It is not a very easy problem to solve. Maybe another example. Face recognition. In the early days, face recognition did not work on dark-skinned people, didn't work on black people, didn't work on African Americans. Because why? Because the model was trained on white people only. So when you run it against black people, African Americans, they do not detect it as a face. This is one of the issues as well of the fairness of AI. AI has to extend and has to go beyond race, beyond religion, beyond nation. Because again, AI is just a tool. A knife is a tool. You can use it to cut your vegetables, but you can also use it to kill people. Similarly with AI, AI is just a tool. At the end of the day, people will need to regulate this. And it's only the government that has the power to regulate this. It doesn't matter whether people have the goodwill. Intel has its own AI ethical board committee. Speaking of, that's a very weird job as well, AI ethical board. You would never think AI would need ethical board. So that's the type of jobs that AI creates. going back to the point. But yes, to that point, governments need to catch up because they're the only ones that can do this, that can put regulations to AI to make sure AI is not used for evil. And the governments are the ones that can protect their people. That would be my stance on this. Yeah.
Maybe one questions from students. Ya, mahasiswa dari Zoom ada pertanyaan? Ada. Oke, kalau sudah tidak ada pertanyaan, kita cukupkan sesi sharing kita hari ini ya. Baik, sebelum kita tutup, saya mungkin ingin sampaikan beberapa conclusion ya dari diskusi kita hari ini. Yang pertama, tadi sudah dipaparkan secara jelas oleh pemateri kita hari ini. Yang pertama, understands the problems ya, engineer. Ya, karena tadi sudah jelas juga dipaparkan bahwasanya kita harus memahami betul dari masalah yang kita selesaikan. Ya. Jadi programmer hanya bisa menulis kode, tapi engineer menulis coding dan kemudian bisa codingnya itu menyelesaikan masalahnya. Kemudian lesson yang kedua ya, don't fight the AI ya, karena kita sudah tahu itu sudah sangat canggih ya, dan kita nggak bisa menghindar dari AI. Alih-alih menghindar, lebih baik kita gunakan AI itu untuk membantu kita menyelesaikan problem ya yang ingin kita selesaikan. Tadi sudah dicontohkan ada satu video yang kemudian model AI bisa mengenerate podcast ya dari dokumen yang diberikan, luar biasa sekali. Kemudian hampir dari paparan tadi ada aturan 90% dan 10%. 90% job yang sekarang mungkin bisa diselesaikan oleh AI dan 10%-nya itu hanya bisa diselesaikan oleh engineers ya, finishing, clean dan lain sebagainya ya. Dan penting juga bagi kita untuk memahami basic knowledge dari teknologi AI itu sendiri, mulai dari coding, struktur data, database dan lain sebagainya ya. Terus lesson selanjutnya Jadi AI itu nggak hanya model development, di balik AI itu banyak sekali proses mulai dari data quality, security, infrastructure sampai dengan product management ya. Terakhir lesson yang keempat, don't trust the AI hype ya. Jadi ada isu misalkan AI akan menggantikan pekerjaan dari manusia gitu ya, atau menggantikan semua pekerjaan gitu. Alih-alih mengganti pekerjaan, bahkan banyak sekali pekerjaan-pekerjaan baru yang kemudian diciptakan oleh AI atau peluang-peluang lain. Terus kemudian AI pun dapat menyelesaikan semua problem, tapi itu juga tidak semua ya problem itu bisa diselesaikan oleh AI gitu. Kemudian AI juga merupakan suatu alat yang besar, big tools yang kemudian hati-hati kita menilai itu apakah bisa menyelesaikan suatu problem atau tidak ya. Dan kita ketika memiliki basic knowledge tentang AI, mungkin kita dapat memilih solusi AI yang tepat untuk menjawab permasalahan dari problem yang kita hadapi. Baik, itu saja sesi kita hari ini. Terima kasih banyak Pak Andrew atas sharingnya ya, sangat bermanfaat sekali buat kami dosen, peneliti, kemudian teman-teman mahasiswa di sini. Oke, mari sama-sama kita tutup dengan membaca hamdalah. Alhamdulillahirabbil alamin. Ya, assalamualaikum warahmatullahi wabarakatuh.